Okay, in this video we're going to look at fractional indices. A fractional index is when you've got some kind of base and the index, instead of being something nice like 1 or 2 or even something like -2 isn't too hard to handle. We know that's going to be 1 over x squared. Okay, instead of having a nice whole number index or power, a fractional index has a power like this. It could be x to the power of a half, or it could be x to the power of 3/4. That's a 4 there. Or it could be x to the power of 6 over 8. Okay, these are fractions as powers. So this is a fractional index. These are fractional indices. Okay, what do we do with something like that? How are we supposed to interpret it? Okay, well, the 8th index law is this. We've so far had 7 index laws. The 8th index law tells us how to deal with these fractional indices. Here it is. If you've got x to the power of some fraction, a over b, then that's going to equal the bth root of x to the power of a. Okay, the bth root to the power of a. Now this must seem strange. Although you've seen the square root symbol before, you probably haven't often seen anything here on the square root symbol, and you're probably very unlikely that you've seen anything inside the square root with a power before. So this is all pretty new. Let's go through it step by step, what it means and how it works. Okay, a simple example of a fractional index that we can work with to begin with is x to the power of 1/2. Okay, x to the power of 1/2. Now, in this case, the a bit on top, that's the 1, and the b on the bottom of the fraction, that's the 2. Okay, so let's translate that into, according to our index law, let's translate that. So it's going to be the root with x to the a, and the a is the bit on top, so that's x to the power of 1, and the b goes out here on top of the square root symbol, and the b in this case is a 2. So we're going to put the 2 there. Okay, so that's how we can interpret x to the power of a half as a root like this. So this x to the power 1, we can see we don't really need to put that 1 there. It doesn't do anything. Anything to the power of 1 is just itself. So we can rewrite that with just x inside. We don't need to put the 1 there. And whenever you have a square root with a 2 here, that's just a normal square root. The normal square root of something. So we don't actually need to write the 2. So we can simplify that down to just this. It's the square root of x. Okay, let's extend our example a little bit. Let's say x equals 4. Let's say x equals 4. So let's do 4 to the power of a half. And that's going to mean we've got the square root of 4. Now we don't need to put the 2 out here because it doesn't do anything. We don't need to put the 1 here because that doesn't do anything either. So we've just got the square root of 4. Well, the square root of 4, you shouldn't need a calculator to tell you, is 2. Okay, the square root of a number says, what do I need to multiply by itself to get this number in here? Okay, you've got to multiply 2 by itself to get 4. So therefore 4 is the square root of 2. Okay, but now we might come up against some other types of fractional indices. So that one's pretty easy when we've got something to the power of a half. Let's say we had something to the power of 1/3. Okay, how are we going to do that? If we go back to our index law, it says the number on top is to the power of whatever the base is inside the square root here. So the a is going to go here and the b is going to go here. So let's rewrite it according to that law. So we've got x inside the square root. This is going to be a 1 because that's a 1 on top, and this is going to be a 3. Okay, so it's the 3rd root, or it's also known as the cube root. The cube root. When you're dealing with powers of 3, it's the cube root. Okay, so we can write that a bit more simply as just x, the cube root of x. Okay, what does that mean? If we're taking the cube root of x, it means we're trying to find what do we need to multiply together by itself 3 times, or actually it won't be x, but it'll be something let's call it y times y times y. We've got to multiply it by itself 3 times, and it's going to give us x. Okay, that's what the cube root will be. The 3 is because we're doing it 3 times now, not just 2 times like you do with the square root, but 3 times now. So let's do an example. Let's say x was 8. Say x equals 8, and we're doing 8 to the power of 1/3. Then we know we're going to rewrite that like this. So we'll put a 3 out here. The 8 goes inside, and we don't need to put the power of 1 there. So we've got the cube root of 8. Okay, so that's asking what number do we multiply by itself 3 times, something times something times something, that will give 8. Okay, now you might be able to figure out pretty easily that that number is going to be 2. Okay, 2 times 2 times 2 will give 8. So 2 is the cubed root of 8. Now most of these fractional indices are not as easy to work out as that one. We can work out the square root of 4, and if we're clever we can work out the cube root of 8, but beyond that it gets a bit harder. Okay, doing the 4th root or the 5th root and anything other than a nice simple number like 8 or 4, it gets very hard. We need to use a calculator. So don't worry if you don't need to be able to do these in your head. You're more than welcome to use a calculator to work them out. What we're just trying to understand though is what it means when you've got a fractional index, what it actually translates into. That's what we're seeing here. Okay, so let's do one more. Let's say we had 5 to the power of 2/3. 5 to the power of 2/3. According to our index law, the 3 goes here, and the 5 goes inside, and the 2 goes to the power of the 5. Okay, so we can simplify that now. 5 squared is 25, and the cube root still stays out the front there. So you could put that into a calculator. Let's see how that's done. Okay, so when you open up your calculator and you go main, it brings up this screen so you can enter in functions. Bring up the keyboard. So you've got all these other options here. Now we want to do the cubed root of 25. So to do that, if you look across these menus here, you'll find 2D, and in there you'll find this special button here, which allows you to enter in special roots. So in this case, we want to enter into this box here, the 3, because we're doing the cubed root, and then inside the root box we put 25. Okay, exactly as it appears there. Then when we go enter, it tells us this number here. Now, if you take that number, take that answer, and then you cube it, watch what happens. So I've taken this answer here, this number here, this 2.924 that's the answer there, and I've said cube it. So multiply it by itself 3 times, and let's see what we get. We get 25 back, okay, because that's doing the reverse process. Instead of taking the cube root of 25, we've got the cube root of 25, and when we're cubing it, it takes us back to 25. So you can see how these are the opposite kind of functions. Cubing and the cube root are opposites. Okay, so let's get rid of the calculator now, and let's try and do a couple of quick problems before we summarize. Okay, here's a couple of problems of the type you're going to have to be able to do. Let's see if we can do them. So 16 to the power of a half. If you remember your 8th index law now, hopefully you've got it in your memory there. When we've got something like x to the power of a over b, then it becomes the root with x to the power of a in here and the b over here. So that's the 8th index law. So this is going to become, we put a 2 here, and we put 16 in here to the power of 1. The 1 doesn't do anything, so we don't need that. The 2 doesn't do anything. We assume whenever we see this that it's a square root. We only do another root if it's a different number up here. So that's the square root of 16, which hopefully you can see is going to be 4, because you need 4 times 4, 4 squared, to get to 16. So hopefully you can do that one without a calculator. Here's another one, 36, and this time it's got 3 on top of the fraction and 2 on the bottom. So let's use our index law again. We're going to have, it's going to equal, I should put my equal sign over here, it's going to equal 36 in here. The 3 goes above the, it's raised to the power of the 36, and the 2 goes out the front here. Okay, so first we've got to do this, 36 cubed. Okay, now a little trick we can use to make this problem a little bit easier is to go back a step, go back to this a little bit, and think about this. 36 to the power of 3 over 2, it's actually the same as 36 to the power of 2 over 2 times, sorry, that should be a 6 there, 36 to the power of 2 over 2 times 36 to the power of a half. Okay, now the reason this is true is because we know that when we've got the same base and they've got indices, we can, and they're multiplied together, we can add these indices together. So we know that that's going to come to 36, 2 over 2 plus 1 over 2 is going to be 3 over 2, okay, which is what we had there. So we can break 36 to the power of 3 over 2 into this. Now the great thing about this is, look at this, 36 to the power of 2 over 2, 2 over 2 is just 1. So that's 36 to the power of 1. So that's 36 to the power of 1, and this is 36 to the power of a half, which is the square root of 36. So it's times, 36 times the square root of 36. 36 to the power of half is the square root of 36. Now the square root of 36 is only 6. 6 times 6 gives 36, so the square root of 36 is 6. So really we're being asked for 36 times 6, which hopefully, if you're any good at your times tables, 6 times 6 is 36, and 6 times 3 is 18, but this is 30, so it's 180. So that's 136 plus 180 equals 216. So we can do that one pretty easily without using a calculator if we realize that we can break up these kinds of things into 2 over 2 and half, because we can add those two indices together to get that. So that makes it a bit easier. All right, lastly, this one over here, 3 to the power of a third. All right, we might have to use a calculator for this one, but let's set it out the way it should be set out. So we can write it out like this, 3 to the power of, that's going to be to the power of 1, so we don't need to write that. The cube root of 3, if we put that into a calculator. So here's our calculator again. Remember, we go to the 2D menu, and here's the special function for roots, and we put a 3 up there, and then in here put another 3, and then answer, and it's 1.44 if we're rounding to 2 decimal places, so 1.44. So it's not too bad. They look nasty, the cube roots, but they're not too bad at all to deal with. Okay, before we move on to before we do the summary, let's just quickly do a couple more problems, just so we know how to do them. Okay, let's say we've got in some brackets a squared times b to the power of 3, that's in brackets, and it's all raised to the power of 1/6. That's an index outside the brackets. If you go back to the first 6 index laws, the straightforward ones, we should know that we've just got to multiply this 2 by this fraction here. The power inside times the power outside. So it's going to be a to the power of 2 times 1/6, and that's going to be b to the power of 3 times 1/6. Well, 2 times 1/6 is 2/6, and 3 times 1/6 is 3/6. And we can simplify both of those. 2/6 is 1/3, and 3/6 is 1/2. So we can simplify both of those. We could write them if we wanted to. If we were asked to write them as surds, which means using the roots, then you could write them like this. That would be the cube root of a, the 3 goes there, the 1 is up here, but we don't need to write it, times, actually I should put another root there first, times the square root of b. So we could write it like that. For this one here, we've got x to the power of 2/3 on top of this fraction inside the brackets, and on the bottom 1 to the power of 3/4. Well, again, we've got to multiply the indices together because we've got an index outside the brackets, so we've got to multiply these indices together. So we're going to end up with x to the power of 2 over 3 times 1 over 2 divided by y to the power of 3/4 times 1 over 2. Okay, now to do multiply fractions together, you do top times top, bottom times bottom, so it's going to be 2 x to the power of 2 over 6 on top, and on the bottom we're going to have y to the power of 3 times 1 on top. It's 3, 4 times 2 is 8. Okay, and we can simplify this down to x to the power of 1/3. 2 over 6 is the same as 1/3. Y to the power of 3/8, we can't simplify that. So there we go, we've got that. Now again, we can turn this into surds if we want. So that would be the cube root of x. Got the 3 on the bottom there, so that goes there. The 1 doesn't do anything. Divided by, it's going to be the 8th root, which is a pretty scary looking root. And it's going to be y to the power of 3 inside. The 3 goes there, the 8 goes there. So there we go, that's how you would express that as a surd. Alright, now let's summarize. Okay, so here's a summary of what we've learned. The 8th index law, there it is, written out. And here's 2 useful things to remember, or it's really one thing, but 2 examples of it. X to the power of 3 over 2 can be rewritten as x to the power of 2 over 2 times x to the power of 1/2. Because this is telling us to add these indices together. 2 over 2 plus 1 over 2 will give us 2 over 2 plus 1 over 2 will give us 3 over 2. That can be very handy because x to the power of 2 over 2 is just x to the power of 1, which is x, and x to the power of 1/2 is the square root of x, which is a lot easier to deal with than doing x, the square root of x to the power of 3. It's a much nicer thing to deal with like that. It's very useful. Okay, thanks for watching. I hope you enjoyed it. Don't forget to do the quiz for this video. Thank you.